When you picture construction, what comes to mind? Probably hard hats, dust, maybe a process that feels like it hasn't changed in, 50 years. But what if I told you that entire industry, one of the oldest in human history, is right on the brink of a massive digital revolution? Yeah, we're talking about a future built not just with bricks and mortar, but with robots, with algorithms, and with artificial intelligence. So let's dig in and lay the foundation for how this incredible shift is actually happening. To really get a handle on the scale of this change, just look at this. On one side, you have the old way, manual labor, working off 2D blueprints, a process that's always been slow, super expensive, and honestly creates a ton of waste. But then look at the other side. This is the new way, robotic automation, all driven by these incredibly precise 3D digital models. The result? Unbelievable speed, optimization, and efficiency. And this isn't science fiction, folks. This is happening right now. And that brings us to our first section, a blueprint for change. So the big question is why now, right? Why is an industry that has literally built our world for centuries all of a sudden being forced to reinvent itself from the ground up?
Well, the hard truth is, the old way of building is kind of broken. For decades, the construction industry has been known as a fundamentally inefficient manufacturing process. It uses up a massive amount of natural resources, has a huge environmental footprint, and is just plagued by high costs and painfully long timelines. All these problems have been piling up for years, creating this urgent need for a much, much better way to build.
And this is the potential payoff. According to industry reports, new technologies like large-scale 3D printing could cut construction time by a staggering 70%. 70%! I mean, when you think about the problems of cost and time we just talked about, a number like that isn't just an improvement, it is a total game changer. So that brings us to Section 2, the new digital toolbox. Okay, so if the old way is broken, what exactly are we using to fix it? Well, it all comes down to a set of connected technologies that create what you could call a digital chain, directly linking a design on a screen to the physical world. At the very heart of this revolution is a concept called digital fabrication, or DFAB for short. And the idea is actually pretty simple. DFAB is just the process of using digital information, like a detailed 3D model, to directly control manufacturing equipment. So we're talking robots, computer-controlled cutters, giant 3D printers, all of them building parts straight from a digital file, pretty much eliminating human error. And this shows the whole workflow perfectly. It all starts with the design, right? You create what's called a 3D Building Information Model, or a BIM. And this isn't just a pretty picture, it's a data-packed digital twin of the building. Next, you can simulate everything, structural loads, energy use, you name it, and you fix problems on the computer before a single piece of material gets wasted. And finally, that perfected data gets sent straight to the machines on site to build the real thing. It's the seamless flow, from click to concrete. But here's the crazy part. This huge technological leap didn't just appear out of nowhere. To really understand where this is all going, we have to look back, because the seeds for this revolution were actually planted over a century ago. Which brings us to Section 3, from modernism to algorithms. This timeline shows this incredible evolution of an idea. Back in the early 20th century, you had modernists like Le Corbusier arguing that a building's design should be driven by its function and made with industrial efficiency. Fast forward to the late 20th century, and high-tech architects took that a step further, exposing the building's guts, its structure and technology as part of the beauty. And all of that leads directly to today's parametrism. This is where architects use algorithms to generate these wild, complex, fluid forms based on data and rules, creating buildings that are super efficient but would have been literally impossible to even design by hand. And this quote from Archdaly's just nails it. This isn't a rejection of the past. Today's digital architecture is a direct evolution of those core modernist ideas: efficiency, being honest about your materials, and using the latest tech to solve problems. It's just that today our tech involves algorithms and robots. Of course, whenever we start talking about robots and AI, there's always that big question that looms over the whole conversation, right? What does all this mean for people's jobs? And that brings us to Section 4, automation and the expert. Now, here's the crucial point. Recent research from MIT suggests we might be asking the wrong question. It's not about if your job will be automated. The real question is which specific tasks inside your job are being automated. And the answer to that question can lead to two very, very different outcomes. This slide highlights a fascinating contrast. Check this out.
When automation takes care of the simple, repetitive stuff, like data entry for bookkeepers, the work that's left over becomes more specialized, and the value of human expertise actually goes up. In fact, wages for bookkeepers went up almost 40% after computerization. But when automation replaces the core expert skill, like a taxi driver's deep knowledge of city streets getting replaced by GPS, the job gets easier for anyone to do. Competition goes up, and wages tend to go down.
So if automation is changing the very nature of what it means to be an expert, it makes sense that it's also going to change how we all work together. What do our new teams even look like in a world where some of our most productive members aren't human?
This leads us to our final section, our new robotic teammates. We need to start thinking about these technologies not just as tools we use, but as active partners we collaborate with. And collaboration requires something that's deeply human: trust.
A new way of thinking about this is called the triangle of design responsibility, and it really helps visualize this new team. You've got the human designer, who's setting the goals and making the final calls. You've got your traditional tools, like CAD software, that just do what they're told. But now there's a third player on the field: generative AI. It has a dynamic role. It acts like an orchestrator, coordinating other tools and even dreaming up totally new design options. So responsibility is now shared between all three.
But any good team is built on trust. And that raises a fascinating and kind of tricky question. How do we build trust with a machine, especially a robot that we're supposed to be working alongside on a construction site?
Well, a study on human-robot interaction came up with a totally surprising answer. When people were shown a robot with a super realistic, human-like face, they actually reported lower levels of trust. They said it felt creepy or deceptive. But when the robot had a simpler, more cartoonish face, trust levels shot up. It seems that when it comes to our new robot teammates, avoiding that uncanny valley is absolutely key to building a good working relationship.
All right, let's wrap this up and look at the key takeaways. First, construction is in the middle of a vital digital revolution, one that's surprisingly built on ideas from 20th century modernism. Second, automation is changing jobs by changing the tasks within them, not just getting rid of roles. And finally, this new era demands real teamwork between humans, AI, and robots, a partnership where building trust is our most important and maybe our most complex challenge.
And this leaves us with one last big question to think about. As we design these increasingly intelligent machines that can design and build our world right alongside us, who or what is ultimately the architect?